5 is bigger than 3, so the arrow should be longer. 5 newtons. And that is, oh, actually, let's do it this way. Perfect. And so my resultant, just the fancy word for sum of vectors, my resultant is from where I began to where I ended, so that would be the total, that blue arrow. Well, I went 3 to the right and 5 to the right, so I went 8 total to the right. Questions to hear? All right, let's make it a little more complicated. The famed box. I have 5 newtons that way to the right. I have 3 newtons to the left. What is the total force equal now?
Two newtons to the right.
Okay, how do we want to represent to the right?
Arrow to the right, pointing at I hat.
I have, okay. So the total force, 2 newtons. Now, some people get confused between my I's and J's. J's I come down and I curl to the left. I's I come down and I curl to the right. The important thing is that that looks like that. All right, so you're in that panic mode. You're suddenly going, wait a second, let me break this down to the basics. Let's do it from the basics. I'm going to add these two forces, so I have 5 newtons I hat. That's going opposite, so that's plus negative 3 newtons I hat. So now I've got 5 plus negative 3, which is 2 newtons I hat. But your mind is still blanking and thinking, if there's only a way I could draw this, well, there is. I start with one of them. I got a starting point right here. I'm just going to start with the 5. I go, that represents 5 going to the right. I'm now here. I add the 3 newtons, so from the head of one, I start with the tail of the other. I come back, 3 newtons. My resultant, or again, sum of the vectors, is just from where I began the whole journey to where I ended the whole journey. That in arrow is my resultant. It is to the right, so it's going to be positive, and it's by 2 newtons. If you haven't picked it out from context, if I'm drawing a vector in terms of form of an arrow, this is the tail, that is the head. Questions up to here, because I'm about to make it a little more difficult. All right, let's make it a little more difficult. A box again, 5 newtons to the right, 3 newtons up. What is the total force acting on the box? And there are 2 ways to express the answer, one of which is simple. The other way involves trig, which is beyond the scope of the course. Unless there's a huge groundswell to do trig, in which case we'll do trig. I'm not sensing an excitement for doing trig. Maybe differently. All right, it's obviously, it's a 2-dimensional problem. I need to somehow add these 2 vectors that in 2 dimensions. Well, I can't get just away with a plus sign. I got 2 directions here. So let's start out where one is starting out. Let's define the I-hat direction. You want to still go to the right?
Yeah.
So I got my 5 Newton, that'll be covered by it, but that 3 Newtons is going perpendicular to that. I need another unit vector. If I'm in 2 dimensions, probably need 2 of them here. Well, if that's I-hat, that's J-hat. They are perpendicular. Sometimes I'll put a little box right there just to indicate that it's the right angle. You want them to be at a right angle to each other. If we went to 3 dimensions, that'd be K-hat. That would be pointing out of the board. That is where we're looking.
So if it was also going down, it would be L.
No, if it's going down, it's negative J-hat. J-hat covers all the vertical stuff. If it's going up, it's positive,
okay.
down, it's negative. If you wanted to do J-hat up and L-hat down, I guess it's, as long as you define it, it's not wrong, but wow, that would really get into some long drawn out answers. Okay, so the way I would write this is, well, I need to add the 2 vectors together. Using my I-hat, J-hat vocabulary, what is this vector?
5 newtons I have.
There we go. So my total force, 5 newtons I-hat. And then I'm gonna add to it this one. What is this?
3 newtons J have.
Done. This is known as rectangular form. Or rectangular notation. If I don't specify, that's fine. Answer, done. If I asked what is the magnitude of the final force, I'm going to do something a little bit more complicated than this. If I'm asking for the magnitude of the force, well, it's helpful to go to the graphic form. I'm going to start here. I'm going to take one of the vectors, and it doesn't matter which one. I'm going to start with a 5, just out of habit. I go 5 to the right. Then I go 3 up. My resultant, as I said before, the sum of vectors, is from where I started to where I ended. That is my resultant. And this is the one place where I use the double print, or whatever chocolate's car costed. All I need to do when I'm asking for the magnitude is to figure out what is the length of that hypotenuse. That is a right angle there. How do you find the hypotenuse if you have the 2 sides of a right triangle?
A squared plus B squared plus C squared.
That's the one. Pythagorean theorem. A squared plus B squared equals C squared, where C is the hypotenuse. So I have 3 squared plus 5 squared is equal to R squared. 9 equals 25. 34 equals R squared. So R, the magnitude, that way. The magnitude is whatever the square root of 34 is, newtons. Questions? Trouble reading my handwriting?
A little bit, but I got it.
Okay. All right. Now, I talked about rectangular form. The other form is called polar form. This is just a side note. If I could figure out what that angle is right there, and it can be done graphically if I have ruler and a protractor, I could do that. With trig, it's gonna be the arctan of 3/5. That doesn't mean anything to you, do not worry about it. But if I could find that angle, and there are mathematical techniques to find it, if I could find that angle, and I'm just gonna make up a number here, I don't know what it actually is, I know it's under 37 degrees, so I'm just gonna pretend it is a 32-degree angle. So if that angle is 32 degrees, I could also write my force in polar form, whatever the square root of 34 is, newtons, comma, 32 degrees, or whatever the angle actually is. This right here is known as polar form, where you give the magnitude and direction. Finding this is generally not a 1/10 thing. There are cases in which, for instance, if this were 5 newtons and 5 newtons, what would that angle be? If it's 5 and 5, what is that angle? I'm finding it hard to believe that no one in here.
Thank you. It's not 5. 5?
No, not 5.
Not 5.
No,
Okay, sorry.
45?
45. 45 degrees.
Um,
If that's a right angle, total, if I add up all the angles in a triangle, it adds up to 180 degrees. 90 of it's taken up here. So that leaves these two have to add up to 90. And because of symmetry, they have to be the same. So these are 45-degree angles.
I'm sorry, where'd you get 34 from?
9 plus 25. I did Pythagorean theorem. 9 plus 25 is 34. And then that's r squared.
You meant for that little equation or whatever? Yeah,
That,
whole, yeah.
because that's equal to the hypotenuse squared. If I take the square root of both sides, I get r is equal to the square root of 34, which is 5 point something.
Okay.
If I had a calculator in my hand, I would actually work it out as opposed to just leaving this the square root form. Did that answer your question?
Yes.
Okay. Other questions? Now, sometimes, I've noticed over the years that the classes that, as a whole, do the best are the ones where the most questions are asked. And there's generally a handful of people who will ask questions, and then other people who are sitting there and either understand it or have no idea how to ask the question. If you're in that latter situation, where you have no idea how to ask the question, but you just don't understand, just take a shot at it. If I don't quite understand what the question is, and no one can interpret, then I'll do a scattershot approach and answer sort of various interpretations I have. Or maybe somebody in the class will go, I know what the person's asking, reword it. But feel free to ask questions. I might look like I'm angry all the time, but if you watch the video, you know that this is my neutral face. My angry face is my happy face. There are differences in there. But most people just view it as angry face. For some reason.
I got another one.
Yeah,
So what is the answer to the initial question?
the initial question, what I have in yellow right here, that is the answer.
And then what was everything else you just did?
Well, how to find the magnitude of the two-dimensional vector. So bring a Pythagorean theorem back into our vocabulary. And then this right here, finding the angle, is just a bonus of, here's a different way of representing the exact same thing.
Okay.
So are the questions you wanted, like rectangular form is the first line, the 5 newtons I have plus 3 newtons I have.
Yeah, that's
And
rectangular
then
form.
the second one would be like, what is the polar form of
Yeah.
this equation? And then the
Yeah.
third one is, what's the magnitude?
Yes.
The square root of 34. Okay.
Yes. Now, if I asked a 110 class, what's the polar form, I better have given you the angle.
Okay.
Because I'm not expecting you to figure out how to find this given the sides.
Okay.
If you know, great. But if you don't know, beyond the scope of the course.
And to find the magnitude, we're always gonna use the Pythagorean theorem.
The word always in there is, if it is a two-dimensional problem, I'm gonna give yes. That does not mean I won't think of an exception later. One-dimensional problem, you could use Pythagorean theorem, but it's gonna be something squared plus 0 squared equals something squared. 3 dimensions, it would be a squared plus b squared plus c squared equals d squared. And I don't think in all the times I've taught 110, I've ever asked for the magnitude of a 3-dimensional vector. Maybe this group will be the one to get there.
So the 34 Newton, that was the magnitude?
Say it again.
34?
This right here? Yes, that is the magnitude.
And how did you do it to find the angle, the 32?
32, you would use trig. So, a 10-second aside for those who have had trig. Technically, theta would be the arctangent of the opposite over the adjacent, so 3/5. On most of your calculators, it would be tan -1 of 3/5. Again, if you don't understand trig, that's okay. This is for those who have had trig and want to connect it somehow. Feeling like we're all experts now. There's a question I've asked on some of the tests. Let's talk about adding vectors. Get a wide variety of answers. I'll leave those up for now. I have an object that's being pulled on. I'll make it 5 forces. Object's being pulled on by 5 forces. What is the total force? This is just a sum of vectors problem. Adding them graphically. When I'm adding vectors graphically, I start with one of the vectors, and it doesn't matter which one I start with. I'm going to start with this one. Why? Because that's where my finger pointed. What I'm going to do is I'm going to draw that vector as best I can with the same magnitude and the same direction. So that should be the exact same length as that. And it looks like I'm off on that one. It should be the same length pointing in the same direction. Did I nail it? Close enough. So this is where I began. I now take one of the other vectors. I typically go counterclockwise. Again, chocolate scars. I'm now going to go to this one. I'm going to take that vector. It should be the same length as the one I just did and the same direction. Because 2 vectors are equal if they have the same magnitude and direction. I'm now here. I've done that one. I'm going to take that one. So if this is vector A, B, C, D, E, that's A, B, C. And now D, I'm going to take that one. Same magnitude and direction, I just have a new starting point. I'm now here. Something like that, that's supposed to be D. And then I take the last one, E. Now I don't have an answer yet. What I've done here is just the equivalent in scalar math is if I asked you what is 1 plus 2, and you answered 1 plus 2 equals 1 plus 2. A true statement, but doesn't actually answer the question. I need to actually draw my final answer, and my final answer is an arrow from where I begin to where I end. This is where I began, and that is where I ended. That is my resultant right there in purple, or magenta, or whatever color that is. I can represent vectors. I guess I have 3 methods now. I've got rectangular form, polar form, and graphic form. Graphical form? One of those. And I think one of the master set questions also does the same thing. That's that. I can take it one step further. I said, suppose A represented, let's say that these are forces. A represents a force that is a magnitude of 3 newtons. What is the magnitude of my final answer? Well, is this smaller than that or bigger than that? Which one's bigger, the purple or A?
Okay.
A is, what did I say,
Bigger.
bigger or smaller?
Bigger.
Bigger, A is bigger. All right, so my answer, the magnitude of this is less than 3. Let's see if I did the fancy right there. Let's look at it like about 2.5. You might look at it and go, oh, that's clearly 2.4. You know, there's a close enough. So the magnitude of R, which I could just write as R without the double print, it's about 2.5. What I'm looking for in a problem like that is close enough.
And that's graphic.
Yes. I have had students dig out the rules, measure, get the exact lengths, pull in a protractor, figure out the angle. Excessive, but not wrong. Questions up to here?
So with the way that you're drawing the arrows, you're trying to get it back towards like A, let's see, like,
Yeah, I want each of these represents one of those, and it
Yes.
should be the same length, same direction.
so how you knew to go that way, because you're trying to go back to connect to A to find the resultant from E to A?